Basic computer architecture, overview, beginner level, introduction. Computer architecture refers to the design and structure of a computer system, including how its components interact to process data. It explains how data moves inside a computer, how instructions are executed, how hardware components communicate, how performance is optimized. Basic computer architecture focuses on the internal organization of a computer, especially CPU, central processing unit, memory, RAM, input-output systems, data buses, and control signals. This topic helps beginners understand how a computer works at a deeper level than just hardware parts. It introduces key concepts such as instruction execution, data flow, memory hierarchy, control and processing units, system design. What is computer architecture? Computer architecture is the blueprint that defines how a computer system is structured and operates. In simple words, computer architecture, how a computer is designed to process data and execute instructions. A beginner view includes input means process means output flow, CPU structure, ALU plus control unit, memory usage, data movement inside the system, instruction execution. Why computer architecture is important. Understanding architecture helps you count, know how programs run internally, count, optimize performance, count, write efficient code, understand system limitations, count, design better systems. Without architecture knowledge, systems may be inefficient, performance issues are harder to fix, debugging becomes difficult. Basic components of computer architecture. Component purpose. Input unit takes input from user. CPU processes instructions. Memory unit stores data and instructions. Output unit displays results. Bus system transfers data between components. Von Neumann architecture. The most common architecture is the von Neumann architecture. It includes single memory for data and instructions, CPU to process instructions, input-output units, buses for communication. Key idea: data and instructions are stored in the same memory. Example of system representation. System equals input, keyboard, CPU, processor, memory, RAM, output, monitor. The CPU has two main parts. 1. ALU, arithmetic logic unit, performs calculations, handles logic operations. 2. Control unit, CU, controls execution, directs data flow. Example: A equals 10, B equals 5. Print A plus B. ALU performs addition. Memory unit. Memory stores data, instructions. Types: primary memory, RAM, secondary memory, SSD, HDD. Example: data equals 1, 2, 3. Stored in memory. Input and output units. Input unit receives user input. Output unit displays process data. Bus system. A bus is a communication pathway. Types: data bus means transfers data. Address bus means identifies memory location. Control bus means sends control signals. Instruction cycle, how CPU works. Step 1. Fetch. CPU fetches instruction from memory. Instruction equals add. Step 2. Decode. CPU understands instruction. Operation equals instruction. Step 3. Execute. CPU performs operation. Result equals 5 plus 3. Step 4. Store. Result is stored in memory. Memory equals result. Simple instruction cycle example: A equals 5, B equals 3. Hashtag fetch and decode operation equals add. Hashtag execute if operation equals add. Result equals A plus B. Result, result. Data flow in computer architecture. Input enters system, stored in memory. CPU processes data. Result stored again. Output displayed. Full menu-based architecture simulation. Python. Def input data. Return input. Enter data. Def process data. Data. Return data. Upper. Def store data. Data. Def output data. Data. Print output data. While true. Print N1 input. Print 2 process. Print 3 store. Print 4 output. Print 5, exit. Choice equals input, enter choice. If choice equals 1, data equals input data. Elif choice equals 2, data equals process data, data. Elif choice equals 3, store data, data. Elif choice equals 4, output data, data. Elif choice equals 5, break. Else, print invalid choice. Concepts learned from computer architecture. Key: how computers process instructions, CPU internal structure, memory organization, data flow between components, instruction cycle, fetch, decode, execute, store. Real-life analogy. Computer architecture is like a factory system. Input means raw materials. CPU means workers and machines. Memory means storage warehouse. Output means finished products. Ways to improve understanding. Study CPU internals, registers, pipelines. Learn assembly language basics. Explore memory hierarchy. Build simple CPU simulators. Learn about cache and performance optimization. Architectures, RISC versus CISC. Common mistakes beginners make. In number 2A, confusing hardware with architecture, not understanding data flow, overlooking memory importance, thinking CPU works alone. Where computer architecture is used. Computer architecture is used in software development, operating systems, embedded systems, game development, AI and high-performance computing, cloud systems, mobile devices. Simple definition. Computer architecture: the design and organization of a computer system that defines how it processes data and executes instructions. Final summary. Computer architecture explains how a computer works internally. It helps you understand data flow, instruction execution, system performance, hardware interaction. Learning this gives you a strong foundation in computing systems.